Hey guys, it's Miss Marflack here. We just finished our kind of unit on logarithms, and before that we did exponentials. And if you can remember, logs has kind of taken us about a month, and now we're embarking on this new topic, and we're going to start trigonometry. Now, I love teaching trigonometry, and it's real shame that we can't be together, but I can't stress the importance enough of getting this foundation here, because thinking about the pre-calc honors curriculum or pre-calc academic, I can speak that in my class in pre-calc honors, we spent from September until February on trigonometry, more advanced trig, but nonetheless, it's very helpful to have this solid foundation here. So I really encourage you to stick around, watch all of these videos in full, get that extra practice on Khan Academy, and email me if you have any questions. We're going to ease into the trigonometry, and we're going to start off with reviewing our two special right triangles, which you should have seen in geometry. And then we're going to take a look at our first three trigonometric functions, which is sine, cosine, and tangent, and that's what we're going to do our SOHCAHTOA. First, starting off with our two special right triangles, you're going to need to know these like the back of your hand, and I really don't usually like using the word memorization, but you should have these memorized, and it can be really helpful to see where these triangles come from, and that'll kind of help with the memorization of the two triangles. Now we're going to start off with the square here. We have side lengths 1, 1, 1, 1, 1. They're all equal, and we're going to drop this diagonal, and we're going to slice this square in half. And then this is a right angle. These are all right angles. So when I cut a right angle in half, I have 45 degrees and 45 degrees. And I'm just going to shade this triangle lightly down here. And we're going to solve for this missing side, which is going to be the hypotenuse of our triangle. We're going to use our Pythagorean theorem, which is a squared, which is a leg, b squared, which is a leg, is equal to our hypotenuse squared. 1 squared plus 1 squared is 2, and that's going to be c squared. And then we're going to have c here is the square root of 2. Now I'm going to draw this triangle for us. This is a triangle you need to know. Your 45, 45, 90. And your hypotenuse is that square root of 2 we saw for, and we have side lengths 1 and 1. All right, so you can see that the 45, 45, 90 comes from a square, and then we're going to use an equilateral triangle to help us find our 30, 60, 90. Now, keeping in mind that a triangle has 180 degrees, so I have three angles here, so each angle is equivalent to 60 degrees. I'm going to start off with side lengths 2, 2, 2 all around. Some teachers do 1, like the square. It's simplest form, but you'll see why I use 2 in a minute. We're going to drop down a perpendicular here, and now what we're doing is we're making this a 90-degree angle, and we're bisecting this angle. So this was 60 degrees. This whole thing here was 60. All right, so this little angle here that's now bisected is going to be 30, and this angle in here will be 60. And then hopefully you're starting to see that 30, 60, 90 forming. Now, since I dropped down this perpendicular, I sliced this leg in half, which means that this is equal to 1, half of the 2. Now, that's why I choose to use side lengths 2, because that way I don't have a fraction here. And then now you can see we almost have, this is going to be the triangle we're working with, and we almost have all three legs. We're just missing this leg over here. So we're going to still use that Pythagorean theorem, which is a squared plus b squared. We're missing a leg, and we have that hypotenuse, which is 2 squared. That's going to be our longest leg. And then we're going to solve for that b squared, and we get 4 here. We subtract the 1, and then we take the principal root, and we get b is equal to square root of 3, and that's going to be this side length here. So I'm going to pull this triangle out for us to see, just like we did here with the 45, 45, 90. Here's our 30, 60, 90. Once again, we bisected that angle on top. We have our 60 degrees, and then we got our 1, our 2, and we solve for our square root of 3. Now, if you're not a fan of, maybe thinking about all this and this is too much for you, that's okay. You really just need to know these two triangles here. And I'm going to label underneath for us. This is our 45, 45, 90, and this is our 30, 60, 90. Now, I don't want to just use these triangles in this form. I want to use them in all of its multiples. So I'm going to drop in an x here. All right, and that shows us that we can multiply any leg, all the legs by, any number here. And we're going to see these triangles in all of its multiples. And then maybe if you're somebody who's not a fan of the visual learning and maybe you like English better, or maybe you're just better at memorizing rules, you can either use these to help solve for missing legs, or you can use these rules. So taking a look at our 45, 45, 90 triangle, we could see, that both legs are equal. So that x and that x, or that 1 and that 1, is equal. And then our hypotenuse, which is going to be our longest leg here, is going to be square root of 2 multiplied by the leg. All right, so if you're solving for the hypotenuse, you take the leg and you multiply it by square root of 2. All right, now we're going to take a look at our 30, 60, 90 triangle. We have two types of legs, so we're going to call this one the short leg, which is 1, and this one the long leg, which is square root of 3. You're going to, if you put in the calculator, you see square root of 3 is greater than 1. So once again, this is going to be our short, and this is going to be our long leg. And then using these rules now, you can take to solve for your short leg, well, that's going to be, in comparison to the hypotenuse, it's going to be half the hypotenuse. And then if you're trying to solve for your long leg, you can see your long leg is your short leg just multiplied by square root of 3 times short. And then if you're solving for your hypotenuse, it's really helpful to have that short leg because you can see it's just 2 times the short leg. All right, so maybe those rules are a little bit more helpful. All right, we're going to take a look at some example problems. And here we are. Our directions are going to be solve for the missing legs. Missing legs. And here we are. We're going to take a look at number 1. Number 1 is a 45, 45, 90 triangle. All I have to do is put in the right angle in the 45. I don't have to label the other angle because we should know that a triangle is 180 degrees. And we're solving for x. All right, you can see here we have our hypotenuse and we're looking for our leg. So I'm going to use the formula, hypotenuse is equal to square root of 2 times our leg. And my hypotenuse here is 6. And the leg is x. And then when I solve for x, I get 6 over square root of 2, but I do have to rationalize by multiplying by square root of 2 over square root of 2. All right, I can't have a radical down there in the denominator. It is not simplified if you have a radical in the denominator. And now I can multiply across. I got 6 square root of 2 all over, and then square root of 2 times square root of 2 is just 2. And then I can simplify even further because 6 over 2 is 3. And then that's going to be our final answer there. Solve for that missing leg. All right, there's number 1. I wish I could fit number 2 on the same page, but I can't. So hopefully you have this down, and then we're moving on. All right, now we're taking a look at number 2, going still with the same directions. Our goal is to solve for those missing legs. So there's our 60, there's our 30, and now we're missing 2 legs, our x and our y, and we're given our hypotenuse again, which is 12. All right, so here we are. We have our hypotenuse. So once you have your hypotenuse, it's a little easier to solve for the short leg and then get the long leg. So I'm going to start off with the formula that our short leg is equal to 1/2 of our hypotenuse. And my short leg here is my x. Now it's really important, maybe I'll draw it off to the side here. It's really important to keep in mind that the short leg is between the right angle and the 60 degrees. So between the right angle and the 60 degrees is the short leg. That's going to be x, and that's going to be 1/2 of our hypotenuse here, and our hypotenuse here is 12. So right away we got x is equal to 6. And then now that we have the short leg, to find the long leg, that's going to be square root of 3 times the short leg. And our long leg here is between the 30 and the 90, and our short leg here is equal to 6. So we have our long leg is 6 square root of 3. Now maybe the formulas aren't very helpful. Okay, well then under this triangle, maybe you can just draw your 30, 60, 90 triangle. So here I am. You can see it's a little rotated from here. And I'm going to draw it underneath. This is our short leg, which is 1, hypotenuse is 2, and then this is square root of 3. And then you can kind of compare, okay, well, 2 to 1 is 12 to 6, and then 1 to 3 is 6 to 6 square root of 3. All right, there's number 2. Moving on to number 3 now. Keep in mind, these are not drawn to scale, so you do have to take a look at the angles. Okay, you can't just judge, oh, this leg looks a little shorter than that leg. 2 square root of 3, x and y. All right, just like the last problem, we're missing 2 legs here. I'm going to start off. I have my short leg, which is between the right angle and 60, and I'm going to solve for that long leg. So I'm looking for my, I'll write a little bit up here, I'm looking for my long leg, and that's square root of 3 times my short. Well, my long leg here is going to be my x. And my short leg here is my 2 square root of 3. All right, so long legs between 90 and 30. All right, and then when I multiply now, square root of 3 and square root of 3 is just 3, and then 2 times 3 is equal to 6. All right, so then now I have my short, I have my long, I can solve for my hypotenuse. Maybe I'll come up over here, where my hypotenuse is 2 times my short leg. And I'm looking for my hypotenuse, which is y, and my short leg here is 2 square root of 3, and we're going to get y is equal to 4 square root of 3. And then, once again, if the rules are not very helpful, go ahead and just maybe draw that same picture and fill in our 30, 60, 90 triangle, where we have 1 here, square root of 3, and 2, and then that might help. All right, you could see to get from here to here, you have to double it, which we did. And then get to here, you have to multiply by square root of 3, which we did. All right, there's number 3. We got 2 more to go. Stay focused. 2 more. Here's number 4. Ooh, another 30, 60, 90 triangle. Those are the hardest ones. I know we've only done 1, 45, 45, 90. We'll do another one. But these are the harder ones. All right, there's that triangle. And we're looking for our x and y. Now this is a perfect example with the way that I drew it, that you can't really tell which one is the long and the short leg. All right, that's why you need to know, kind of going back to that picture on the first page of our notes. Do I have it? Do I have it? Yes, I do. All right, that's why you got to go back to this picture here and see that your short is between 90 and 60 and your long is between 90 and 30. And that will help here. All right, so when I have this leg between 90 and 30, I have my long leg. And I want to solve for my short leg here, so I'll use that rule that my long leg is square root of 3 times my short leg. And my long leg is 5 and square root of 3, and my short leg, what I'm looking for, is x. Now I have to solve for x, which means I'm going to divide on through by square root of 3, and then I do have to rationalize the denominator here because this is not in simplest form. And then when I multiply, I have 5 square root of 3 all over 3. Now I can't simplify that any further. 5 and 3 have no common factors. All right, and then now that we have our short leg, it's a little easier to find your hypotenuse because your hypotenuse is 2 times your short leg. All right, so my hypotenuse here is y, and my short leg is 5 square root of 3 all over 3, so that 2, or multiply by 2, will go in the numerator, and I'll have 10 square root of 3 all over 3, and then there is my long leg. And then once again, Miss Marfleck writing this picture under here for those of you who maybe just don't like using the rules. We have our 30, 60, 90. This is our long leg, this is our short, and there's that hypotenuse. Okay, last one. Here we are, number 5. And number 5, we're finishing off with a 45, 45, 90 triangle. All right, this is another way to kind of represent a 45, 45, 90 triangle. You have the 90-degree angle, and then those two little tick marks show us that these two legs are congruent, so we can assume that it's a 45, 45, 90 triangle. We're looking for our hypotenuse, our longest leg, and that's going to be square root of 2 times any leg that we have. And our hypotenuse here is x, and our leg is 9, so x is going to be 9 square root of 2. And then drawing that pretty picture for us. If you draw these triangles enough times like Miss Marflack does, you will have them memorized, no problem. All right, here we are. That's it for 30, 60, 90. So one more just kind of quick scan here. Our 30, 60, 90 and our 45, 45, 90, I mean. There is our notes deriving them. These are our triangles. Here are our rules to kind of help solve. We did 1 example down there. We did 2 and 3 up here. And we did 4 and 5 down here. Make sure you have all that. All right, now we can move on to SOHCAHTOA. And SOHCAHTOA is really where we start working with the trigonometry, and we needed to do the triangles because trigonometry is all about relating side lengths of a triangle to its angles. So here you could title the top of your paper, SOHCAHTOA. And you're going to see what that means in a minute. First, we're going to start off by defining, what our hypotenuse is. We should know by now that it is our longest leg. I said it a few times, but really it's going to be the leg that's also across from our 90-degree angle. It's going to be across from our 90-degree angle. And with the SOHCAHTOA, we're going to have to label which one is our hypotenuse. So I want us to know that this is across from the 90-degree angle. And then we're going to also use another name. Instead of using hypotenuse, that's going to represent one leg of the triangle. Another leg of our triangle is going to be called our opposite side. And our opposite side is going to be across from the angle that we're working with. I'm going to put here this. That denotes angle, but your angle could be x, it could be theta, it could be anything. This is usually the notation you use in geometry to denote an angle. So it's going to be across from an angle, and it's going to be not touching the angle that you're working with, not touching the angle that you're working with. And then our adjacent leg, or our adjacent side, will be the side that creates, or you can think of the side I used in like the last touching. It's touching the angle, creating the angle or touching the angle. So if I had a triangle, here, let's say, and I'll use my angle to be theta, okay, let's say my angle is theta, then my hypotenuse is my longest side, or the one across the 90-degree angle. My opposite leg is the one that's across from the angle, but it is not touching the angle at all. And then adjacent is the one that helps create the angle, because this is the angle we're working with, creates this angle, and it is touching. And then let's just throw theta in a different spot just to make sure we're good, with what all of these legs are called. Once again, hypotenuse across from the 90 degrees. Opposite is going to be across from the angle, and adjacent is going to be touching the angle. Adjacent will be touching. All right, we're almost done here. We don't have much left to do. Now we're going to define our SOHCAHTOA. So we define these trigonometric functions of an angle to be the ratio of sides of a triangle. And for our sine, we abbreviate it to be SIN. And this theta here can be any angle. It can be x, it can be alpha, it could be beta. So maybe I'll put in here in a different color. Could be X, could be, alpha, could be beta. Sometimes in geometry, we use capital letters. Could be an A, could be a B, could be a C. But sine of theta is going to be our opposite leg over our hypotenuse leg of the triangle. And then we have our cosine. We abbreviate COS of theta, is going to be our adjacent leg over our hypotenuse. And then lastly, we're going to have tangent here, which we abbreviate tan of theta, is going to be our opposite leg over adjacent. All right, and then this is where the SOHCAHTOA comes. So we have sine, big S, is opposite over hypotenuse over H. Cosine, big C, that is going to be A over H, adjacent over hypotenuse. And then T here, that's going to be our opposite over adjacent, SOHCAHTOA. Now, please, please, please do not say sin and do not say cos, okay? This is sine, and this is cosine, and this is tangent. All right, only 3 more examples to go, and then you're home free, and then you just got to do a little bit of work, and then you're done for the day. All right, here we are. We're going to take a look at an example. We'll take a look at one, and I'll draw the triangle for us first, and then I'll tell you what we're solving for. All right, so here's a triangle. I'm going to label this angle A, this one B. We'll label this one C. This is side, I'll put the angle notation in there. This is side length 12, this is side length 9, and then 15. We're going to solve for our sine of A, angle A, our cosine of angle A, our tangent of angle A, sine of angle B, cosine of angle B, and tangent of angle B. All right, switching to a different color here to denote the problem from the answer, starting off with sine of A. So here we are at A. That's going to be opposite over hypotenuse, which is 12 over 15, but that's not simplified. So we're going to divide on through by, let's see, 3 here, and we're going to get 4 over 5, and then that is simplified, 4 over 5. All right, cosine now of A, that's going to be our adjacent leg over our hypotenuse. That's going to be 9 over 15. When we divide, that's going to be 3 over 5. Taking a look at tangent of A, that's going to be opposite over adjacent. That's 12 over 9. Dividing on through by 3, we're going to have 4 over 3 here. Now we're switching to angle B. Sine of B is opposite over hypotenuse. That's going to be 9 over 15, which is 3 over 5. Cosine of B is adjacent over hypotenuse. That's going to be 12 over 15, which is 4 over 5. And then tangent of B, that's going to be opposite over adjacent. That's going to be 9 over 12, and that's going to be 3 over 4. Now, you may have noticed that this is our 3, 4, 5 triangle, which is a Pythagorean triple, but there are our answers. All right, moving on, just 2 more to go. Here is number 2. All right, we got a triangle. The side lengths are a little bigger now. We're still going to keep it going with the ABC notation. Why not? This will be A, this one will be B, this one will be C. Putting in those angle markings. 30, short leg is 16, and then hypotenuse is 34. And then you guessed it, we're going to do the same thing here. We're going to do sine of A, cosine of A, tangent of A, sine of B. Notice how I read the trig function, okay? It is tangent of the angle B, okay, of B. All right, switching to a different color, denoting the problem from the solution here. Sine of A, we're going to start off here. This is going to be opposite over hypotenuse. Well, that's going to be 16 over 34. We can divide numerator and denominator by 2, and that's 8 over 17. Cosine of A, well, that's going to be adjacent over hypotenuse. That's 30 over 34, dividing numerator and denominator by 2. That's 15 over 17. And then tangent of A, opposite over adjacent. That's going to be 16 over 30. And dividing numerator and denominator, we get 8 over 15. All right, now we're switching from angle A to angle B. Sine of B, opposite over hypotenuse. That's 30 over 34, and when we simplify, that's 15 over 17, dividing by 2. Cosine of B, adjacent over hypotenuse, that's 16 over 34, dividing by 2, that's 8 over 17. And then this last one here, of tangent of B is opposite over adjacent, and that's 30 over 16, and that's 8 over, no, that's 15. What am I doing? 15 over 8. 15 over 8. All right, so there we are. There's number 2 completed, and then we got one more to go. Stick around for this one. This one is a very important one, and that's number 3. And here we are. We have this triangle. Ooh, not very straight. That's okay, though. Here's A. Here's B again. Here's C. Right angle, angle, angle. We have a radical now, so we have some simplifying to do with that radical. And I should have maybe said it in the previous example, but maybe you noticed that this was another famous Pythagorean triple, our 8, 15, 17. Okay, now I can move on to number 3. All right, we're looking for the same thing here. Bit repetitive, but that's okay though. With the foundation of trig, it can be a little tedious, but you really need to know these trig functions inside and out. As you start off, maybe the first few problems you're glancing back and forth at your notes, seeing what Miss Marfleck did, seeing how to do it, and then maybe after a few, you're starting to feel really good about knowing all of these definitions. All right, starting off with our sine, we're going to do sine of A. Well, that's going to be opposite over hypotenuse, so that's 2 square root of 3 over 4. And then when I simplify here, 2 over 4 is 1 over 2. And then now cosine of A, that's going to be adjacent over hypotenuse. And when I simplify here, I get 1/2. And then tangent of A, that's going to be opposite over adjacent, and that's going to simplify to square root of 3 over 1. All right, now sine of B, we have opposite over hypotenuse, that's 1/2. Cosine of B, that's going to be here adjacent over hypotenuse, which is 2 square root of 3 over 4. We simplify that. And then tangent of B, opposite over adjacent here. So we have 2 over 2 square root of 3. That's going to be 1 over square root of 3. And then peep here, I do have to rationalize. All right. And then when I rationalize, I'm going to have square root of 3 over 3. All right, and then maybe you notice that this triangle is a special right triangle that we just worked with, and that's our 30, 60, 90. Here's 60, here's 30, here's square root of 3, 1, and 2, and you can see it's a 30, 60, 90 triangle, just a multiple of 2. All right, so we did do a lot today, but, really make sure that you know all these definitions because the trig will pile up fast. So make sure you're looking back through your notes, and while you're doing the practice problems, keep looking back at those 2 special right triangles that we started with. All right, email me if you have any questions.